Hi, welcome to my video on the combination of transformations on the parabola. This video is going to talk about reflection in the x-axis, the vertical stretch, the horizontal translation, and the vertical translation. The order of transformations is reflection, stretch, and translation. That's the order that you will perform on when you transfer or transpose one figure to its image. Reflection, stretch, and translation. And I call reflection R. I call the stretch S, and I call translation T. So the reflection is always in the order of R, S, T. R, S, T. And if you notice, that is the same letters in the alphabet, or the order, same letters. The order of the alphabet, R, S, T. Reflect, stretch, and translate. And that's the way I perform the transposing or the transformation on the basic graph. Could be a line, could it be a parabola. That would be reflect, then we stretch, and then we translate. Okay. State the equation as y equals a times x minus h squared plus k for each parabola if it's reflected in the x-axis. So reflected in the x-axis means that the a is going to be a negative because the parabola is going to go down. And when it's reflected left, that's left, so that's a minus 4, but in the equation it's a plus 4 because any number that we put in a bracket is always the opposite. So notice left to the left is a minus, so it's a plus. So when I put a minus 4 in the place of x, we get this expression right here becoming 0. And 3 up is a plus 3. So that's the equation. Notice again, when we do the horizontal translation, whatever you have is the opposite. So it's left is negative 4 plus 4. And up and down is true to the value of up is plus, down is minus. A vertical stretch of 6, that means that A is 6. And right to right means a plus 2. So the equation is not reflected, so the A is not negative. So we have a 6, but no negative because it's not reflected. And right 2, that's in relation to the translation, so we have x minus 2 squared. And there's no plus or minus on the end because it didn't go up or down. Down 7, nothing, there's no reflection, there's no vertical stretch. It says down 2, so it's just the x squared minus 7, down 7. So notice there's no brackets because there's no horizontal translation. There's only a vertical translation of a minus 7. Reflected in the x-axis with a vertical stretch of 1/3. So the reflected in the x-axis means you're going to have a negative. The vertical stretch is going to be 1/3. So that means A is 1/3. So we have y negative 1/3 x squared. And we have an x squared. There's no bracket with the x like here because there's no horizontal translation and there's no vertical translation, so there's no number on the end. E, 8 right, 5 down. There's no reflection and there's no vertical stretch, so y equals 8 right is a plus 8, so that's an x minus 8. Again, just to remind you, the horizontal translation, whatever it is, the equation has the opposite. Down 5 is a minus 5. So that's the vertical translation. So that's a minus 5. Again, note the equation. When you plug 8 sub 8 in the place of x, this expression becomes a 0, so y becomes negative 5. That's your vertex. So the value of x that gives you 0 in this expression right here is the x coordinate of your vertex. And that is also, the value of x is also your horizontal translation. And again, inside of this bracket, whatever you have, it's always the opposite. So if I got a plus 8, it's a minus 8. And if it went left 10, 10 left, that's a minus 10. And there's no reflection. There's no horizontal or vertical stretch. So left 10 is in terms of the horizontal. So it's an x plus 10 squared. No number on the end because it didn't go up or down. No vertical translation. Okay, here we go. Complete the chart. We have these 5 equations. We're going to fill in each of these. In this equation, I have a negative. The A, I have a negative here, so reflected, yes, because it's negative. Because of the negative. Again, because of the negative. The vertical stretch is the number in front of the x squared, which is 4. And the vertical stretch is always positive, never negative. It's the absolute value of the A, that's the vertical stretch. The absolute value of A, which means the absolute value is never negative. It's always never negative. The horizontal stretch, there's no bracket here, so the horizontal stretch is 0. The vertical, the horizontal translation is 0. The vertical translation is plus 9, so that's a 9. And the vertex is the horizontal translation of 0 and the vertical translation of 9. Number 2, reflected in the x-axis, the answer is no, because we have a positive 1 here. That's a positive, so no, because we have a positive. The parabola opens up. The vertical stretch, we could say, is neither one, but it's 1. 1 is the number in front, so the vertical stretch is 1. And we have a horizontal translation, that's plus 4. So the horizontal translation is a minus 4. It's 4 left. And the vertical translation is a minus 2. It went 2 down. Again, the opposite of the bracket is the horizontal translation. And the vertex is negative 4, negative 2. Because it went 4 left, 2 down. There's your vertex. And next one, we have a negative. It's a yes. It's a yes because of the negative. I just draw. It's a negative. So it's a yes. It's reflected. Vertical stretch is a 1. The 1 understood to be there. It's always a vertical stretch of something, but when it's a 1, that means the basic equation is not changed in relation to the width. And the horizontal stretch is the opposite, so it's a plus 3. And there's no number on the end, so it's a 0. So the vertex is 3, 0. And the next one is a no reflection, because there's a positive. Because it's a positive, it's opening. Notice it's a positive 2, so it's opening up. And the vertical stretch is the A value, which is 1/2. And the horizontal stretch is a negative 1. The horizontal translation, better be careful. The horizontal translation is negative 1, opposite to this bracket. And the vertical translation is 6. And the vertex is negative 1, 6. Again, opposite to what's in the bracket, so negative 1. So when you place a negative 1 in the place of x, this becomes a 0. So that's why y is 6. So negative 1 gives you 6. That's the vertex. And the last equation, we have a plus and a 1. So there's no reflection because of the plus. The stretch is 1 because the value of A is 1. And there's no bracket, so that's a 0. and it's a minus 4. Went 4 down. So the vertex is 0 minus 4. Now let's graph this parabola. And when we graph a parabola, again the basic parabola is y equals x squared. So what happens when we look at a parabola? When we graph from an equation, or we always look for its table of values. So the table of values that we're going to use depends on where the vertex is, because you don't want to keep naming a whole lot of numbers. We try to narrow it in. So the vertex is the opposite of this, -2, which is a 2, and the same as this one, -1. So we take the vertex of 2. Notice, if you put 2 in the place of x, you get a 0. 0 squared is 0. Minus 1 is -1. So when we put a 2 in place of x, we get a -1. That's the vertex. We put the vertex in the middle of our table. We take the 2 and the -1, place it in the middle. That means we'll take numbers above that, which is 3 and 4. We take numbers below that, which is 1 and 0. And we sub in these numbers. So the 3 subbed in the equation. So we'll put a 3 in the equation and work it out. And we work out the inside first to get a 1. 1 squared is 1. And 1 minus 1 is 0. And I don't even have to do this one, because if I move 1 unit to the right and 1 unit to the left of 2, I get the same y value because it's symmetrical. And again, you can plug into 1 in the place of x if you want and work it out. So 1 and -2, 1 subtract 2 is -1, -1 squared is 1, 1 minus 1 is 0. Now I'm going to put a 4 in. 4 in the place of x. X minus 2 squared minus 1. 4 minus 2 is 2. 2 squared is 4. 4 minus 1 is 3. And I know that this one is going to be a 3, because when you move 1 unit to the right and left of the 2, you get the same y value. When you move 2 units, you get the same y value because it's symmetrical. So let's graph this parabola. 2, -1. X is 2, y is -1. Notice it's positive also, which means that it's going to go up. And notice that the stretch is 1. So this parabola is going to be the same width, will fit on the basic parabola. Only the numbers are shifted left and right and up. And we got a 0. 3 gives me a 0. 3 gives me a 0. And 4 gives me a 3. 4 gives me a 3. And we go to the other side. 1 gives me a 0. X is 1, y is 0. And x is 0, y is 3. X is 0, y is 3. So we have our parabola. Let's go on like this. And just, there it is. Notice the parabola is opening up. And notice that the vertex is right there. Vertex is 2 and -1. Okay, let's graph number 2. Again, we always start from the vertex. The vertex of this equation, x, what's in the bracket, is x plus 1. So the x-coordinate of vertex is a -1. Why? When you put a -1 in the place of x, -1 plus 1 is 0. 0 squared is 0. -2 times 0 is 0. So the y is 0. So when you put a -1 in and work it out, you will get this number here. And this number here happens to be no number, so it's understood to be 0. We put the vertex in the center of the table, right in the middle. -1, 0. We take a number above that, which is 0. Take another number, which is 1. We take a number below that, which is -2, and a -3. So I'll sub in 0 in the equation. 0 is going into place of x, and I'll work it out. So 0 plus 1 is 0, 0 squared, 0 plus 1 is 1, 1 squared is 1, so we get a negative 2. We put a 1 in the equation, so we get 1 plus 1 squared. We're subbing 1 into place of x. That's 1 plus 1 is 2. We work out the bracket. We do exponent, and then we multiply. So 2 squared is 4, and we get a negative 8. So that means that the negative 2 is going to give me the same as 0. And the 1 give me negative 8, so the negative 3 will give me negative 8 because it's symmetrical. If you plot this, if you get the vertex correctly and put these numbers in correctly, you only got to do half the workings because it's symmetrical. Notice. So negative 1 gives me a 0. X is negative 1, y is 0, right there. That's the vertex. When x is 0, y is negative 2. When x is 0, y is negative 2. When x is 1, y is, x is, what have I got here? X is, oh, now look what I did. I said x is negative 1, y is 0, and I went on the wrong side. I was wondering why I was. So when x is 0, y is negative 2. When x is 1, y is negative 8. Right down here. When x is negative 2, y is negative 2. When x is negative 2, y is negative 2. When x is negative 3, y is negative 8. Now this makes more sense. I started off just then putting it there by mistake. So you can see it's symmetrical. There's the vertex of negative 1, 0. And when you move 1 unit right, you get a negative 2. When you move 1 unit left, you get a negative 2. So symmetrical. So here comes the parabola. And if you had a graphing calculator and plugged that equation in, then it would look just like that. You could plug this one in the graphing calculator and it would look just like this if you have a graphing calculator. So, except for that little ear right there, put in the wrong spot, talking too much, not paying attention. So, but I did correct myself because I knew the parabola had to be symmetrical on each side. And find the equation of the parabola as a times x minus h all squared plus k for each. Well, let's find the vertex first. The vertex is 1, x is 1, y is 1, 1, 1. So that means I have a y and I have a 1, so that's an x minus 1. And the y coordinate is 1, so that's a plus 1. So notice the opposite of this one, not this one. There it is. Notice it's going up, so we have a plus. And how do I get the stretch? Well, if you move 1 to the right, which I'm going to do, from 1 to a 2, and then I find how much I go up or down, there it is. So when I move 1 to the right, whatever this is right here, that's a 2, so that's my stretch. When you move from the vertex, 1 to the right, or 1 to the left, and then you go up and find the point that it goes through, that's your stretch right there. But that happens at 1 only, because in the basic graph, when you have a 1, in the basic graph, y equals x squared. When you have x is 1, you get y is 1. When you have x is negative 1, you get y is 1. So this is only true on the parabola. When you move 1 unit right or left, you can move up, and that will be your stretch. It won't happen when you get a 2. When you move 2 and you move, you notice you get what? From a 5 to a 1 is a 4. So you can't tell. You got to be careful. Only when you move 1 unit. And number 2, what I want to do, just for a second, I want to take the table of values and move it sideways. Here we go. And then you could also look at his graph. So x is 0, negative 1, negative 2, negative 3, negative 4. That's a negative 12, negative 3, 0, negative 3, negative 12. You could also draw a quick graph of it. Notice the vertex is negative 2, 0. So the vertex is negative 2, 0 here. When you go to a negative 1, you get a negative 3. When you go to negative 3, which is right here, you get a negative 3. So you can see that this is your sketch of your parabola. When you do that, you notice that the y values from 0, the y's are going negative 3, negative 12. The y's are going down from the 0. Or you can see it in your table of values. You can see that the y's are from the 0, you go to a negative 3, then you're going to a negative 12. Or you can see it's the same thing here. But here you can see you got a 0, and so that's in the middle. So these are tapered away, so you can see they're going down. Or you can draw a graph. But whatever way you decide, here we go. We have the vertex is negative 2, 0, because that's what's in the middle. So that's an x plus 2 with a 0. I didn't need to put the 0 on, but I just put it there. Notice it's going down, so we have a negative. Going down, so it's a negative. And if we move 1 unit to the right there, there's the 1 unit to the right. And what do? We count that. That's 1, 2, 3. So the stretch is 3. You can see 1 unit you go from, and the stretch can't be negative, so it's a 3. So the equation is negative 3 bracket x plus 2 all squared. That represents this table of values. And hopefully that will help you when you think about transformations on the parabola, but not only on the parabola, but it'll also be on the absolute value. It'll be on the equations when we deal with the graphing, the roots, square roots, and things like that. So very important to know about transformations. If you like my video, click the like button, the subscribe button, and notification bell. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.